Again, the homework sheet you should have already done over the weekend. Matter of fact, I think I have it. Let me pull it up. Let me just double check. It may or may not be in here. If it is, awesome. If it's not, that's okay. It's going to look a little bit different than your sheet, but that's fine. All right, this should be it, correct? Awesome. So what I want to do, like I said, I want to go through these naming compounds. And if you can do these without any hesitation, if you're going to fly right through them, which again, the last time we took this test, a lot of you in this room had trouble with this. So number one, you need to go back and review your polyatomics before tomorrow, because if not, you're going to do just as poor as you did in the past. But if you know your polyatomics and you know how to do this, then the empirical formula part should be the easy part. Yes, sir. We may do them a little bit later, but I haven't had a chance to really get that under my belt. Okay. Now, again, the first question, Brett, that you have to ask yourself whenever doing any naming compounds is what? What type of bond is it? Okay. Is it covalent or is it ionic? So if you look at the first one, it has, what is P? Phosphorus. If you have to literally come in here and write the letter N for nonmetal, then do it. If that helps you, then do it. What is Br? Bromine, metal or nonmetal? So, if you've got a compound with two nonmetals, then what type is this? Covalent. If you literally have to come in here and write the two letters covalent or three letters, do it. Do whatever makes it easier for you. When you have covalent bonds, what must be present in the name? Prefixes. When does the first one get a prefix? Only when it's more than one. Is the first one have more than one? Yes. And what is the prefix for two? Di. Okay, so this is di something. And di what? Phosphorus. Very good. Phosphorus. When is the second we get a prefix? Always. And what is the prefix for four? Tetra. Okay. Now, and it's not tetrabromine, it's tetrabromide. Very good. Tetrabromide. Diphosphorus tetrabromide. Moving on to number two. Again, the first question you must ask yourself is what? What type of bond is it? So we got copper. What is copper? It's a metal. Chlorine is a, so this is ionic. If you literally have to do that, do that. Whatever makes it easier for you. Okay? Now, we know that copper is going to be written. So, whenever we have ionic bonds, what do we not have? We have zero prefixes. So, I'm going to write copper. Now, copper is a metal, but what kind of metal? Transition. Does it need something after it? Yes. It needs a what? Roman numeral. I'm going to go ahead and throw this at you. There are three exceptions. Why every day during 7th period, this board just completely quits working? There's a good chance of that. 3 exceptions. Wow. Who are they? Seriously? Hold on. So zinc, cadmium, and silver. Now, if you want to do the other 3, totally cool with that. If you want to write this down somewhere, it may be a good idea. Top, bottom, back, wherever. Now, why? Stop. Don't these 3 have Roman numerals? Very good. They're always the same. They never change. Now, what is cadmium's charge always? 2 plus. What is zinc's charge always? 2, and silver is always a 1. Those are the 3 that will never change. They're always going to be those 3. So there's no reason for you to put a Roman numeral behind them because we already know what they're going to be. But copper is not one of those exceptions. So we've got to figure out what the Roman numeral is. Now, but I'm going to keep writing because I know I'm going to come back to it. So what does Cl turn into? Chloride. Now, Here's the problem, and I'm going to come off of this page and I'm going to come to this one just to make it a little bit easier. CUCL. What is the process called in order for me to determine what my Roman numeral is? Reverse crisscross. Now, the problem is I have no numbers to crisscross. So what are they? They're understood ones. Okay, so I pull back a 1 plus and I pull back a 1 minus. But again, and this is the part where this class has had trouble. As soon as you do this, what do you have to check? You've got to check this backside number. How many of you say that that is correct by a show of hands? How do you know that is correct? It's in group 17, and all group 17s are -1. So, if this is right, then is this right? Yes. So, which copper is it? Copper 1 chloride. Okay, copper 1 chloride. All right, let's look at the next one. You've got phosphorus and oxygen. Are those two metals, two nonmetals, or a metal and a nonmetal? Two nonmetals, which makes this thing what? Covalent. And as soon as you tell me it's covalent, what do you better have in your name? You better get some prefixes in there. Now, the first name is just like number 1. It's going to be diphosphorus. Diphosphorus. But the second name is going to be a little bit different. Again, I ask the same question. When does the second name have a prefix? Always. And what is it for 5? Penta. But remember, this time, because it's oxygen, we got that funky vowel thing going on. So what letter do you drop? The A. So it's not pentoxide, it's what? Pentoxide. So diphosphorus pentoxide. Pentoxide. Yes, sir. No, if you do leave it, I will not mark it wrong. It's not 100% accurate, but it's not 100% wrong, so I'll give you credit for it. Okay? It's one of those things that I want you to get to the point where you don't do. All right? Now, the next one. Number 4, Mg. Who is Mg? Magnesium, metal or non-metal? Metal. And as soon as you see this big old thing, what are those things called? What's the last word? Ions. And ions make up what type of bond? Ionic. So if you see a polyatomic ion, then it has to be ionic bonding. Okay. Now, who is Mg again? Magnesium. Now, what group is magnesium in? 2. Now, here's what I found out some of you do. Because you either A, don't know the rules, or B, you're just trying to make sure you have a better shot of getting it right. You either never put Roman numerals, or you always put Roman numerals. That's what I figured out some of you do. You're like, I don't know when to put them, so I'm always going to put them. That's not right. What groups don't? Groups, not elements. What groups don't need them? 1 and 2. Is magnesium in 1 and 2? So keep right on moving. You don't even have to worry about it. So let's keep right on trucking. And now you just got to recognize that thing, which a lot of you still have issues with. What is that thing in parentheses? Phosphate. Not ite. Phosphate. So that is magnesium phosphate. Now, polyatomics, like you are Bailey, right? She is Natalie. That is phosphate. If I changed it to PO3, that's something totally different, right? You just got to recognize which polyatomic that it is and name what it is. Does that help? It's kind of like whatever the formula is, that's its name. Like you're Bailey. No one else in here is Bailey Black. Okay? I can make someone dress up like you, but they're still not you. It's like if I change that to 3, it kind of looks like it, but it's not it. All right. Let's look at the next one. Who is Ag? Silver. Now again, just like I said last time, we've got a metal, but we've got a polyatomic ion, so this has to be ionic. Now, as soon as you see silver, something should kind of go off in your head. And we just wrote it just a few minutes ago. What do we know about silver? It's an exception. So what do you not need in this one? You don't need a Roman numeral in this one. And there's nothing you can do to know that other than memorize it. Like you can't just see that and say, okay, well, That's a transition metal. It doesn't need a Roman numeral. Now, you've got to memorize that silver is one of those that doesn't need it. And finally, you've just got to recognize this polyatomic. And what would it be? Nitrate. Now, I do want to come back off of this page, and I want to point something out. Nitrate. Silver nitrate. And here's what I want to point out about this one. AgNO3 is exactly how it's written. So my question to you is, why are there no parentheses around that polyatomic? There's nothing to protect it from. Because up here there was a +1, back here there was a 1 minus. Well, what do those things do? They cancel it off. So really, I don't have to protect it from anything. It's free to just kind of hang out. Okay? Okay? All right. The next one. 6 should have been easy. Some of you knew that before you even knew how to name compounds. But let's just kind of go with what we have. Carbon, metal or non-metal? Non-metal. Oxygen, metal or non-metal? Non, so you've got 2, so what is that? Well, that's covalent. All right. And anytime you have a covalent bond, you've got to have prefixes in it. Will the first word have a prefix in this one? No. Massimo, tell me why not. Yes, sir. What was my question? Yeah, just making sure you knew the question. Sometimes they do. Look at 2 and 1 and 3 have prefixes on the first one. Very good. Okay, so it's carbon. Now, Brennan, does the second one need a prefix? What would it be and why? Now, very good. It's 1, and this is one of those the weird O things again. So drop the O on mono, and it's carbon monoxide. Again, some of you already knew that before you even began this class. All right, number 7. We've got carbon, which is a non-metal. Hydrogen, what is that? Non-metal. So you've got 2 non-metals, so what is this? Covalent. Okay. Jesus, does the first one need a prefix on this one? What would it be? Tetra. Thank you. And it's tetra what? Very good. So tetra carbon. Tetra carbon. Why does the second one need a prefix? What will it be? Deca. Now, guys, I have seen this class have this problem. When you see this word right here, and I'm just going to write it right here. When you see this word, what element better be present in the formula? Well, you can say actually 2. You can say there better be a hydrogen and there better be a what? In this formula, C4H10, what do you not see? Oxygen. So what can't you put in this thing? You cannot put that in there. I saw a lot of you put hydroxide for elements that had no oxygen in there with it. That's a mental thing that you have to catch. So if it's no oxygen in there, then it's just hydride. Get rid of the ox in it. Because what is hydroxide's formula? OH negative. It's totally different. Okay, so coming back to the answer sheet, it's deca hydride. Decahydride. Okay, now looking at number 8. Any questions on any of the ones so far? Anybody that has already done these, have you gotten all of them right? Okay, very good. If the ones you missed, do you know why you missed them? Number 8, lithium. What type of element? Metal. Hydrogen is a? It's a non-metal. So we got a metal and a non-metal. So what type are we working with? Covalent. Whoa. Wrong. That's wrong. Come on. What type are we working with? Ionic. Thank you. All right, so we're working with an ionic. Who is the first one? Lithium. Very good. Now, again, I keep asking this same question. because I assure you someone is going to mess this up. Does lithium need a Roman numeral? Why not? It's not an exception. It's group 1. Okay? It's group 1. What two groups don't get them? 1 and 2. Please don't mess that up. Group 1s and group 2s never have Roman numerals in their name. Okay? Now, same thing as the last question. It's hydrogen by itself, and so it's hydride again. Now, this next one, I'm going to come off of this page. We can come back and fill it in just a second. I just need a little bit more room. So, CrOH3. My first question is, what type of bond? There's two ways you know. You've got a metal, and you have a polyatomic ion. So, it's got to be ionic. Now, who is the metal? Chromium. Ryan Howard, does chromium need a Roman numeral? Yes, it does need a Roman numeral. Now, I'm going to pause for just a second. I know it needs one. Jamila, who is OH? Hydroxide. All right, Blaze. How do I get the Roman numeral? What do I do? I don't know if I follow. What's the process called? You sure about that? Thanks, Bailey. So, what's understood to be right here? A 1, so that's 1 minus. Where does this go? It goes up there. Again, I cannot beg you enough. Once you do this, there's something else that you have to check. Marquise, what do you have to check? And if you don't know your polyatomics, you are in trouble. Is that right for hydroxide? Yes. Well, if that is right, then this is right. So this is chromium what? There's your answer. Chromium. Brett, dude, you were killing me. You got to stop. Chromium 3 hydroxide. Okay. Yes, ma'am. Yes, ma'am. Automatically. Okay. And then the last one, I'm not even going to take the time to write because you should know it. It's covalent. And what is Xe? Xenon. And what is the prefix for 6? Hexa, Hexa. And then fluorine turns to fluoride. So xenon hexafluoride. I have one more that I want you guys to practice because it's a little different from ones we've done. I'm going to kind of walk around and watch it. I'm going to give it's a funky one. If you get this one, I have no fear in you getting any of them right. All right, so I gave you the hardest part. Well, technically not the hardest, but it is vanadium. Now, some of you caught this. There were 1 or 2 of you that didn't, but that's okay. This is why this is practice. So whenever you actually get to this on the test, you need to catch it. Both of y'all. Both of y'all. Y'all are both contributing to this. What is PO3? Phosphite. Now, here's why this could cause some of you trouble. Who does that 3 belong to? The oxygen. You cannot take it. But why was this thing not protected? There was nothing to protect it from. So apparently either they were 1s or they canceled. So we got to figure out what it was. So we know that because you can't steal the 3, it's technically a 1. So we brought up a +1, and we brought back a 1 minus. And again, this is the part that either you know your polyatomics or you don't. And there's nothing I can do but tell you to memorize those. Is that right? No. What is phosphite supposed to be? 3. So multiply this to 3 minus. This goes to 3 plus. So what vanadium is it? Vanadium 3 phosphite. Okay? Vanadium 3 phosphite. All right, so let's jump over on the other side. Let's do some of these. Now, if I were you and I got this test tomorrow, I would start on this side and I would find the ones with all the prefixes and do every single one of them first. Why? They're the easiest ones. You literally just write down what you see. But some people in this class are messing this up. So let's find, what's the first one where you see a prefix? The first one. 13. So we've got sulfur, tetrafluoride. Now here's my question. And again, some of you were doing this. Does the prefix stay with the element that it's attached to, or does it go with the one it's not attached to? The one it is attached to. So that the 4, which is tetra, belongs to who? F. What is the prefix for sulfur? There isn't one. So it's just SF4. Simple, straightforward, boom, you're done. What's the next one with prefixes? 15. Dinitrogen dioxide. How many nitrogens you got? 2. How many oxygens? Now, this is where some of you are going to mess up. Don't be that person. Should I reduce that? If I did, is it still dinitrogen dioxide? No. So if you reduce it, the name changes. So that's wrong. Never, ever, ever reduce covalent compounds. Let me ask you something else. Is that, number 15, an empirical formula? What is the definition of an empirical formula? Simplest. Can that formula be simpler? Yes. Trish, you may want to come get this. Now, what's another one that has a prefix? Number 17. Tricarbon octahydride. How many carbons? 3. How many hydrides? 8. Okay. Now look at 19. Sulfur hexabromide. So what you got? SBr6. And then finally, dinitrogen pentoxide. What you got? N2O5. Now here's the best news. You've just started this test and you've already got 5 of them right. You've got 100 so far. If you did this part right. Get your confidence up. Go ahead and do these. These are easy. Okay? If you then you feel more confident going back to the other side and naming the ones with prefixes, do that. But I would start with those first. Get those out of the way and get your confidence up that you can do this. Now, if you hate polyatomics, leave those for last. So the only ones that don't have polyatomics that are left are 12 and 18. So let's do 12 and 18. So what is the symbol for lead? PB. And I want you guys to do it just like I do it. And I'm begging you because it's going to make it easier. Now, what is the number in parentheses in Roman numeral? 4. Where does that 4 technically belong? The charge on who? Lead. The Roman numeral belongs to the transition metal. After you crisscross. But it's the charge initially. Stay with me. Okay. Now, oxide. What is that? Guys, do you agree that this is an ionic bond? Now, since it's ionic, what must be present? No. Ions. Ions. Real quick. How many ions do you see? First of all, what is an ion? Something that is charged. How many charges do you see up there? 1. If it's an ionic bond, how many must have charges? Both of them. Well, what in the heck is the charge on oxygen? How do you know it's -2? It's in group 16. That's the part where students in this class mess this part up, is you don't know how to assign charges to elements that are not polyatomics or not metals. It's in group 16, so it's -2. Now, we can do one of two things. We can go ahead and in our brain reduce it, or we can crisscross it and then reduce it. So if I just go ahead and crisscross it, would you agree that I got PB2O4? can I leave ionic compounds that way? What do you do with that thing? Reduce it. So this reduces to PbO, and there's supposed to be a 2 right there. You can barely see it though. Pb, and I scribbled it out. So PbO2 is your final answer. Okay. Again, if you hate polyatomics, let's skip to the one that does it. Let's go down to 18. Manganese. What's the symbol for manganese? Mn. Mn. What number is that in Roman numeral? 6. So that tells me it's Mn 6 plus. Now, nitride. What is that? N by itself. Now, again, is this ionic? How many elements are ions currently? One of them. We got to make both of them ions. What group is nitrogen in? Try again. 15. -3. Okay, so let's assign it -3. It's just these problems just work out that way. It's not always because that. I mean, if I would have picked oxygen, it would have been 6 and 2, and it would have been a third. You see what I'm saying? It just sometimes whenever you have even numbers, it works out that way. Because if I would have said manganese 7, nothing would reduce with it, right? So it just kind of happens. That's how it works. All right, let's look at that. Just since you asked, if it was manganese 7 plus, nitrogen 3 minus, what do you do with those things? Crisscross. So it's Mn3N7. Okay, but we're not working with that one. We're working with Mn6 plus N3 minus, which gives us Mn3N6. But can I reduce that to what? Mn2, and that's the final answer. Okay. It just so happens that the two that we've done reduce down like this. They're not always going to reduce, but if they can, do it. And then the ones that you guys hate, the ones with polyatomics in them. But once you have them memorized, they're actually the easiest ones because you don't even have to think. You just write them. Now, calcium. What group is calcium in? It's in group 2. So it's a calcium 2 plus. And what is phosphate? PO4 3 negative. If you don't study those tonight or you don't know them, you will fail this part tomorrow. Guaranteed. Guarantee it. Now, will either of those two numbers cancel or reduce? Nope. So let's just crisscross them and keep them. So I've got Ca3 PO4 2. So like I said, once you know your polyatomics, this is much easier. Kelly? Gotcha. Okay. Number 14, strontium hydroxide. Okay. All right. Which color 3? Orange or red? Okay. So this right here, that is what you have to have memorized. That is the charge on phosphate. All those polyatomic quizzes that we took, it's 3. I promise it's 3. Sulfate is 2. Phosphate's 3 negative. Over here, if you reverse crisscross, that's 3 minus, and that's 2 plus. You with me? Okay. All right. Now looking at number 14, strontium. What group is strontium in? It's in group 2, so it's a 2 plus. And what is hydroxide? OH negative. And when you crisscross here, are you going to have to keep the parentheses? Yes. So it should be SrOH2. And then finally, the last one, we've got copper 1 sulfate. What does that Roman numeral 1 tell me? the charge on copper, so it's copper plus, and then sulfate, and again, you just have to have it memorized, is SO4 what? 2 negative. SO4 2 negative. And when you crisscross, do you have to keep the parentheses this time? Nope. So it's just going to be Cu2 SO4. Are you feeling a little better, maybe, possibly, hopefully, about this? 14 SR parentheses OH close parentheses 2. Everybody good? Yes, ma'am. Cu2SO4. Are there any of the empirical molecular formulas that you guys want me to do? All of them? I will tell you that this one, number 17, was PbC8H20, which was really funky. Yes, if you get that, the first time I did that, I was like, no, it's kind of funky, but it's right. The tetramethyl lead. Good, as long as you got it. Massimo, step 1, convert grams to moles. Step 2, divide by the smallest number of moles. And that should give you 1, 8, and 20. Okay? Before you add, what is the mass you put for lead? What did you divide? Okay, that's right. Go back and multiply by 3. Everything by 3. The original value. Yes, sir. 20. All right, guys, I'm going to do number 20, but I will need your help on this because I'm going to have to get off this page and I'm going to help finding the numbers. So what, first of all, did they give them to you in percentages? What do you do with all the percents? Drop it and change it to grams. What's the percentage of carbon? 49.48 grams of carbon. Lily, have you done this one? Can I see it, please? I just need numbers. All right. We've got 5.19 grams of hydrogen. We've got 16.48 grams of oxygen and 28.8 grams of nitrogen. Guys, if you're not writing this down, I'm giving you a free problem. Okay. Now, we got grams. What do we do next? Convert it to moles. Now, I'm just going to do it short and quick. So we've got grams, we've got moles, grams, we've got moles, grams, we've got moles, and then grams into moles. All the moles are what? 1. Carbon is 12.01, hydrogen is 1.01, oxygen is 16, and nitrogen is 14.01. Yes. Now, let me ask you this as you're writing this. When you actually plug this into your calculator, the values that you write down have to be in what format? The correct number of significant figures. Okay, just throwing that at you. So this one should be 4.120. This one should be 5.19. This one should be 1.03. And this one should be 2.06. That is a 0 at the top. Yes, my bad. That's not a 6. And that's a 9. And this is 2.06. All right. Now we've got our number of moles. What's your next step? Divide by the smallest. Either way, it's not going to make a difference. Because this, you're only off by 5 hundredths. You see what I'm saying? Now, of the 4, who's the smallest? All right, oxygen, so 1.030. When you divide these out, here's the numbers you get. You get 4, you get 5, you get 1, and you get 2. If you plug it in the calculator, it'll tell you that. Say it again. Just divide it and look and see. Now, here's my question. Guys, read the question. It's after all the numbers. It's the second sentence. It says, find the empirical formula. Do you see a formula anywhere in my answer? No. So what did those red numbers turn into? Subscripts. Now, I don't know if I've told you this, but this is something important. What order do I write the elements in? The order that they're given in. Okay, I have told you that. Very good. I'm surprised I said that. C4, H5, O, N2. And this is the EF. And again, what does EF stand for? Empirical formula. And what's the definition of empirical? Simplest. Can that be any smaller? Nope, that's it. But here's the second part. It then asks, find the molecular formula. And if you know one formula, you know how to do this. Does anybody know how to convert from EF to MF? It's the mass MF over the mass of the EF. Now, my first question is, where does that top number come from? It's given to you. Look in the problem. It even says if its overall molecular mass is 194.22. So I plug that in on top. So 194.22. This is the hardest part of this entire problem. Everything else has been simple. How do you get the mass of the EF? You have to find the mass of this thing. I can assure you the one I give you is not going to be that big. Mine will be a little bit easier than that. Okay, but it's like 97.11, I think. Anybody confirm that? Is that it? 97.11? Now, some of you are math wizards, and you can look at that without even having to punch into a calculator and tell me that that number comes out to be what? 2. If you're not confident in that, plug it in and see what it comes up to. It'll be 2. You can look at it and tell. Half of 194 is 97. Or another way to look at it, Lauren, what's half of 22? That's the easier way to look at it. Yes, ma'am. How did I get 197? No. Check. 194.22 is given in the problem. This number, it's 4 times carbon's mass, plus 5 times hydrogen's mass, plus 16 times 1, plus nitrogen's mass times 2. Just like we've always done. Add them all up. Now, but here's the last little part. This comes out to be 2. That's not a formula. What do I do with it? Multiply it by all those red numbers. So the final answer is C8, H10, O2, N4. And that's it. Lily. Thank you. Any questions while we're still looking at it? Ask now. Yes, ma'am. Lily actually had all of them. I will double check it to see if it's right or not. Lily, do you still have yours out? Will you get it out just to confirm it with her?